Hello and welcome to all. In today's lecture, we are going to discuss the next point or next unit, that is push down automata. Here, this one is the syllabus for push down automata. Here, in this push down automata, we want to discuss the definition of push down automata, basic definition. After equivalence of final state and empty state acceptance by PDA. After that, PDA and CFG, as well as CFG and PDA. After that, parsing and PDA. In that, top down parsing, bottom up parsing using deep PDA, and closure and decision properties of the PDA. So first of all, push down automata. Here PDA, that is push down automata, which was introduced by Anthony G. Oettinger in 1961. In 1961, Anthony G. Oettinger, which was introduced the PDA, push down automata, and further studied by Robert J. E.P. in 1963. So we know that regular expression, which is shown graphically with the help of finite automata, as well as described by using the regular expression. So we can represent regular languages with the help of regular expression. We can show it graphically with the help of finite automata. But there are some languages which are other than regular languages, like non-regular languages are also present, and that we cannot describe with the help of regular expression, as well as we cannot draw its equivalent finite automata. So there is a need. There is a need of another approach, which so we can represent all kind of CFL languages graphically. So FA, which is not sufficient to model all kind of CFL. So here there is another approach which will show the graphically, that is nothing but PDA. PDA is nothing but push down automata, or it is also called as finite automata with stack. So push down automata is used to represent all kind of CFL, that is regular as well as non-regular type of languages. PDA is nothing but FA with stack. Okay, push down automata is nothing but finite automata with stack. PDA, which having the memory. We know that finite automata does not consist of memory, or it having limited memory. But here PDA having the memory in the form of stack. Okay, PDA which consists of three operations: push operation, pop operation, and no operation. In short, it is called as NOP operation. So these three operations we can do with the help of PDA. So first of all, we will see the working of PDA. PDA, here you can see PDA consists of one input tape, which is divided into identical square. Each identical square is called as cell, and each cell consists of input symbol of the string. Here, suppose string having 2A, after that 2B. So here these 2A and 2B are placed inside the input tape, which having some finite control, which will control the activity of the read head. So read head will going to read the current input symbol, and it will going to perform the operation with the finite control. Finite control will going to read the input symbol, as well as it will going to perform the operation, and push operation, pop operation, sorry, or no operation on the stack. PDA, push down automata. We'll see the definition, which is represented by using 7 tuple. Here capital M indicate that capital Q, that is capital Q summation tau delta Q0 F and Z0, where capital Q is finite non-empty set of state, or the total number of states which are required to design the PDA, push down automata, for the given problem definition. Summation, set of input alphabet. Tau are nothing but set of stacks alphabet. Now we are inside the stack, whichever symbol we will to place, whichever symbol we will to push, that will be the set of stack symbol, and that are represented by using this symbol too. Delta is a transition function, mapping function, or next state function. Here delta is nothing but current state into current input symbol. If you don't have the current input symbol, that time it will be summation, epsilon into step symbol, topmost step symbol. It will decide the next state, as well as stack operation, push operation, pop operation, or no operation. Q0 is the initial or start state of the PDA. F is the set of final state or states. There may be the case we may have more than one final state, and Z0 is the initial stack symbol, which is present in the this set of stack symbol. And delta is the transition function. Now there are three operations that we can perform on the stack: push operation, pop operation, and no operation. So first of all, push operation. We know that what do you mean by push operation? Inside the push operation, we have to insert the input symbol onto top of the stack. Let us consider initially stack is like this. Here stack is shown, which will consist of two symbols. Z0 is the initial stack symbol. After that, B is the topmost stack symbol. This is the current stack. So delta Q0, after reading the current input symbol, suppose inside the string current input symbol is A and topmost symbol here it will be B. So after performing push operation, we will be, let us say we are in Q1 state and will going to perform push operation, means here B is replaced with AB, okay, or A will be now top of the stack symbol after performing the push operation. This will be the so here B topmost stack symbol is replaced with AB, and now stack will be like this. Now for pop operation, delete the topmost symbol of the stack. Pop operation is nothing but delete the topmost symbol from the stack. So how to perform? Suppose this one is the stack. Again, you can consider this one is the stack, okay, which will have the current topmost symbol is TOS. Means TOS indicate topmost symbol and current topmost symbol is the P. So Q0 is the current state, A is the current input symbol. I am saying that input symbol, input or tape symbol, and B is the topmost symbol of the stack. So if after reading B topmost symbol, we are going to perform the pop operation. Means we are going to delete this B. So B is replaced with epsilon. So once we will replace B with epsilon, now stack will be like this, which will consist of only Z0 and top of the stack is decremented by 1. So top of the stack is pointing towards the Z0. Now third operation is no operation or NOP. So here this indicates that we have to keep the topmost symbol of the stack as it is, okay, and that indicate that which will perform the no operation on the stack. Means initially stack is like this. Suppose stack which will consist of Z0 is the initial stack symbol and B is the topmost symbol, which will be TOS, topmost stack symbol. So after performing Q0, current input symbol, let us say in the tape A is there. So A, after reading A and topmost symbol is B. So we are going to keep that B as it is. We are in Q1 state and B will be as it is. So after performing no operation also, stack will be B is the topmost symbol and Z0 is initial. So TOS is pointing towards B. This is no operation. So this is no operation. Here you can see B will be as it is. Now ID form of the PDA. ID is nothing but instantaneous description of the PDA. So let M be the PDA, which is defined by using total 6 tuple, capital Q, finite non-empty set of state, summation, set of input alphabet to stack symbol. Delta is the transition mapping function or next state function. Q0 is the initial state. F is the set of final state and Z0 is the initial stack symbol. Then ID, means instantaneous description of PDA, is defined by using triplet, and that triplet is defined by using delta, transition function. So delta is nothing but current state, capital Q, into current input symbol. If you don't have the current input symbol, then we will going to consider epsilon as a current input symbol into topmost symbol of the stack. We will be in the next state as well as next topmost symbol, means after performing push, pop or no operation on the stack. Here you can see delta Q0 is the current state, A is the current input symbol, B is the topmost symbol of the stack. After reading it, we are in the Q1 state and we are keeping that B as it is, means we are performing no operation on the stack. So after that, stack will be like this. This is no operation. So in this way we can show the ID form of the PDA push down automata, where Q0 is the current state, A is the current input alphabet or tape symbol, B is the topmost symbol of the stack, Q1 is the next state, B is the new topmost symbol. Here we have performed no operation, thus B is the new topmost symbol. After stack operation, no operation. So here you can see after no operation, stack will remain same, and this is nothing but ID form of the PDA. Now language accepted by the PDA. Here acceptance of the language will be done with the help of two ways. Means language accepted by the PDA with the help of two ways. One is with the help of empty stack and second one is with the help of final state. So first of all we will say acceptance by the final state. After accepting the given input PDA, PDA enter into the final state. So here in case of final state, the given input is suppose ABA. So after reading that ABA input, stack will be enter into the final state. And that concept is called acceptance by final state. Let M be the PDA, M be the machine which will represent the PDA for the given language, which is shown with the help of total 7 tuple, capital Q, summation to delta Q0, F and Z0. Then the language L of M language which will accepted by the machine M is called as acceptance by final state, which is given as LM equal to curly bracket W. W is some word which belongs to the given language, which will be from current state Q0, word is W, Z0 is initial stack symbol. By processing, star indicated by processing it by using the machine M, we are in Q1 state, where Q1 is the final state. Q1 is final state. Epsilon indicate that we have read the total string. Means epsilon means string is empty, and alpha indicate that stack content which are remain after the processing of the given string by machine M. Okay, where alpha are the content which are not relevant to the given string. Now acceptance by empty stack. Here acceptance by empty stack is nothing but after accepting the given input by the PDA, stack will become empty. Okay, stack will become empty, and that concept is called as acceptance by PDA. In previous case, stack having some content, Z0 must be there. Okay, at least Z0. But here we are going to delete Z0 as well in acceptance of empty stack. Let M be the PDA which is accepted by using this total 7 tuple, capital Q, finite or empty set of state, summation, set of input alphabet, to stack symbol, delta is transition mapping or next state function, Q0 is initial state, F is the final state, and Z0 is the initial stack symbol. Here F will become 5. Here we don't have the final state. Be a PDA. Then the language LM, language which is accepted by the machine M is called as acceptance by empty stack, is given by LM. L is the language which is accepted by the machine M. We are having some W word which belongs to the given language. Then Q0 is the current state. By accepting the current input string, Z0 is initial stack symbol. So we are going to star indicate that we are going to process the given string with the help of machine M. We are in Q1 state, where Q1 is not in the final state. Epsilon indicate that total string is processed by the PDA, and this epsilon indicate that now the stack is also empty. That is, the PDA M read the entire input W, enter into the state Q1, where Q1 is not the final state, and stack will become empty. This is called as acceptance by empty stack. We'll stop here. Thank you.